Good day, viewers. You are welcome to my YouTube channel, Maths with Adevi. I'm Victor Adewale Adeleke, and here we are solely focused on teaching you mathematics from the basic even to tertiary institution. And like I say, mathematics is not really difficult. And those of you that are watching my video for the first time, do not forget to subscribe, and do not also forget to hit the notification bell, like and share, as it is very, very important, so that next time when I post materials like this, you will always get notified. Now, what we have here today is indices and logarithms. Now, like I always tell you, indices is not a problem, nor is any mathematical topic a problem. But one thing you must understand is that you must understand from the beginning, which is the root of the equation, and you must understand why is that thing provided. Remember what I always say, that indices is like a summary. It's a summary, like if you are talking about English, if you go to English, for example, we have summary in English. In mathematics, we don't call it summary, we call it indices. Indices is like a simplified form of sum of mathematics. Instead of having a lengthy or too much words, you just try to summarize them using your indices. We have several laws of indices. I will not tell you that we have 7 laws. As many persons will say 7 laws of indices. No, I don't know how I'm doing that concept. But there are multiple laws of indices, and if you understand them, you will know how to jar them to solve your problems. Now, let's start first of all with laws of indices and logarithm. Now, like I said, I told you just now, I said some persons will say 7 laws, but I will not stick with that 7 laws. We have a law. This one is called the product law of indices. X raised to the power of A times x raised to the power of B is equals to x raised to the power of A plus B. I'll be teaching you indices and logarithm together today, and maybe in my other video or any video that I post today, I will talk about an extension of indices. And an extension of indices is what we know as logarithm. Now, logarithm is an advance. I call it an advance of indices because logarithm can provide solutions to problems that indices cannot. For example, we have 5 raised to the power of x equals to 8. In this kind of place now, logarithm is what will help you scale through. But when you have 5 raised to the power of x equals to 25, you can use indices in such a problem, but it doesn't work like that here. So you must understand that. So what we are going to now do here is that this is x raised to the power of a times x raised to the power of b equals to x raised to the power of a plus b. If you know this law very well, which means if you say 5 raised to the power of 10 times 5 raised to the power of 6, we can say 5 raised to the power of 10 plus 6, and you get 5 raised to the power of 16. Summing up the powers together. This is how it works. But now we want to try to use this same method to explain a logarithm, because this is called the product law for indices. But for logarithm, we also have another product law also, because like I said, they are similar to each other. So I'm going to be comparing both indices and logarithm together. Now, if this law holds true, we are trying to prove now the law of logarithm. What we are going to do here is note, or let's just say let n be equals to x raised to the power of a. That's the point I'm trying to prove out. Let n be equals to x raised to the power of a. If n is equals to x raised to the power of a, like I said, the golden rule of mathematics, take log of both sides. And if you are doing that, you have log n equals to log x raised to the power of a. Like I said earlier, take what? Log of both sides. And if you are taking log of both sides, it is very, very simple. All you must understand is that just take the log here and the log of the other place. Then another law you must note is that a log x is equals to, it's a law in logarithm. A log x is equals to this a, which is at the beginning here, can be taken here, can be transposed here as the power. So it becomes log x raised to the power of a. So we now have log x raised to the power of a. Now once you add that, very simple. From here, that's what we are going to do here now. So if this law holds true, a log x is equal to log x raised to the power of a, then we can say that this a can be inverted backward. So we have a log x raised to the power of a. Okay, no power a. Why no power? Because we have taken what a backwards already. So from here now we have that log n is equal to a log x. We can call this one equation. We can call this one equation 1. Now if you done that, the same procedure is what we are going to repeat. Let n be equals to x raised to the power of b. The same thing. Once you've done that, then you do what? You take log of both sides. The same step that I explained. Take log of both sides. Taking log of both sides, we have log n equals to log x raised to the power of b. So let's just be asking questions in their mind. Does this log not have a base? Yes, it has a base. But this is called a natural log because I'm not putting any base here. So it's a natural log of 10 automatically. But if I'm putting a 10 there or any other figure, which means that's the base it has. But in this case now, we just have log n and base. Nothing. So which means that there's a 10 there by default. So understand that system. So we have log n is equals to log x raised to the power of b. Once you add that, now then you apply this law that I gave you. What was the law? B can go to the back now. So we are going to have that log n is equals to b log x. Now once you add that, you can call this one equation 2. So we have added that log n is equals to b log x. Once you've gotten that, then the next thing to do, we have got equation 1 and equation 2. Don't get confused. What we are trying to do is we are trying to prove this is the law of indices. We are trying to use this other law to prove the law of logarithms. So my next video, I will start providing solutions to questions using Excel, following Excel labels and their questions so that we can get very used to these stuff. They are not difficult like I always say. So log n is equals to b log x, which is equation 2. And log n, we found out that log n is equals to a log x. Once you've done that, then the next thing to do, just say m times n will be equals to what? Now if n is equals to x raised to the power of a and n is equals to x raised to the power of b, we can substitute that into this. So when we say m times n, we can just say, instead of writing n, we already know that n means xa and n means xb. So which means that m times n is still going to give me this answer. So I can say x raised to the power of a plus b. Following the law of indices, I'm still on point. I've not done anything absurd or anything weird. I'm still on track. So m times n is equals to x raised to the power of a plus b. Once you add that, now you can take log of both sides. Taking log of both sides, like I always say, what the golden rule of mathematics, whatever is done to the right hand side should be done to the left hand side, and the equation remains the same. So that's what we are doing here now. So if you are taking log of both sides, you have that log n times n would be equals to what? Would be equals to log x raised to the power of a plus b. Now once you add that, so we have now that log n times n is equals to log x raised to the power of a plus b. Now the law I stated just now that when you have a or when you have log, okay, let me write it properly. When you have log x raised to the power of a, it can be a log x. The same thing. So log x raised to the power of a is equal as a log then your x. So the a has gone to the back. So that's what we are going to give you now. So since we have the a raised to the power of a, sorry, x raised to the power of a plus b, we can revert it backward and we say that what x, sorry, we say a plus b and we have log x. Then what do we have here? We have log what? N. I'm putting log mn. Why am I putting log mn? Because that's product rule. So once you add that, now let log x enter into the bracket. You expand the bracket with log x. Normal mathematics or factorization. In factorization, you are going to understand that system. So log x multiplies a, we have a log x plus b multiplied, we have b log x, and we have this one log n. This is a formula in logarithm. Well, I know many of you must be looking at it now confused, saying you've not seen anything different. No, but look at this. A log x in equation 1 is what? It's log n. So we have that one log n is equals to what? A log x. A log x is what? is log n. So we have log n plus b log x. What is b log x? Okay, b log x of equation 2 is equals to what? To log n. So we have log n. So this is a standard equation in logarithm. This is a standard equation in indices. So like I said, I'll be teaching you to. I'll just solve this one today and prove the formula for logarithm, because I told you earlier on that if you must understand the system of mathematics, you must understand the concept, the beginning of it. So that's what I'm trying to do, to make sure that I demystify all these beginnings for you, so that you know how this formula came about, then you know how to apply them. So once you've noted this one now, another law of indices that I would like to show us today is x raised to the power of a divided by x raised to the power of b equals to x raised to the power of a minus b. This is standard law of indices also that we were taught in secondary school, senior secondary. Particularly, they teach us this from this course, that x raised to the power of a divided by x raised to the power of b is equals to x raised to the power of a minus b. So what does that mean? Which means 5 raised to the power of 10 divided by 5 raised to the power of 3 can be written as 5 raised to the power of 10 minus 3. So which will be, or 10 minus 3, we have 7. So this is a system of operation. But in this case, we are going to try to bring out, this is product law, this one is division law. So this is product law for indices, this is product law for logarithm. So this is product law, division law for indices now. We are going to provide division law for logarithm also. So what are we going to do here? Very simple. Just the same step that I followed. That's what we are doing. So you just say what? Let still n be equals to x raised to the power of what? A. And we should not waste our time. Since we already know that what? That we have already got to equation 1 and equation 2. Let's just go with that. We have already got to equation 1 and equation 2. So recall, we already have that was log n is equals to what? A log x, and log what? Log n is equals to b log x. So this was equation 1 and this was equation 2. Now once you add that, once you've gotten this one, now all you just need to know is come straight to this step. In this place, it was product law, so we say m times n. But here now, division law, so it's going to be n divided by n. And another thing you must note, worthy of notes, very important, notes. It has been given already that n is equals to what? X raised to the power of a, and n is equals to x raised to the power of b. Once you've gotten that, then the next thing to do is what? Log. So just say n divided by n will give you what? Now what will n divided by n give you? N is already what? X raised to the power of a, and n is already x raised to the power of b. So we have already now that n is equals to x and n is equals to x to b, which we have. Now from this place, now what means this is m already divided by n. You can see from that angle that this is m divided by n. Why? Because n is equals to xb and n is equals to xb. So therefore, you must give us this answer, this solution, x raised to the power of what? A minus b. Secondly, once you noted this, take log of both sides. Like I always say, the golden law of mathematics. Whatever happens to the right hand side happens to the left hand side. So when you take the log of both sides, log n divided by n is n equals to still the same log of the other side, x raised to the power of what? A minus b. Then the principle that I've explained, this a minus b will be inverted like I've explained. So we have log n over n equals to what? Equals to a minus b, and we have log x. Log x. Once you've done this, what do? We expand the bracket, normal mathematics, which we learned for what? For factorization. So when log x enters into this bracket, we have that what? It becomes a log x minus b log x. So here we have what? Log n over n. So what is log n over n now? From this formula, a log x has been seen from equation 1 to be what? To be log n. So therefore, proven log n divided by n must be equal to what's a log x now? We have found out that a log x is equals to log n minus b log x is what? Log n. We have gotten this one already. So this is the standard law of logarithm, and this is a standard law of indices. Now the two laws now, so I can share them into parts. I can differentiate them by saying this is indices and this is logarithm. So for product law, the product law for indices, we have x to the power of a times x to the power of b equals x to the power of a plus b. In similitude, the logarithm product law is going to be what? It's going to be log of mn equals log n plus log n. And so also the other law, this is one which I would approve, and 2, x to the power of a divided by what? By x to the power of b would be equals to x to the power of a minus b. Once you've done that, then in similitude, like I always say, log m divided by n is going to be equals to log n minus log n. These are constant laws that govern indices and logarithms in the whole universe. Now, these are not just the laws of indices and logarithms, though. There are many other laws that I will explain as time goes on. In my next video, I will teach you how to solve questions using these laws, and I will be bringing a white question also with me so that we can attempt those questions, understand them, and if you have any questions or any problems pertaining to these indices and logarithms, drop them on my comment section. Do not forget to subscribe, like, and share this video. Remain blessed and stay tuned.